Okay, so we are going today to go from word equations to equations with symbols, and we're also going to balance these equations, okay? So first we're going to start by writing what we call a skeleton equation, which just means everything has the right formula, okay? Everything has the right formula. So we're going to start with number one. Number one says sodium chloride plus or and, the same thing. Sodium chloride and lead 2 nitrate. What's the arrow mean?
Product.
Say again?
Yield.
Product.
Yes, yields or produces lead 2 chloride and sodium nitrate. Okay, so remember we did some sample problems like this the other day. Okay, so we are, I muted myself. Trying to turn it up. Okay, so we're going to start by making sure we do our formula correctly first, okay? So, John, just tell me the symbol. Can you tell me the symbol and charge for Na?
Oh, +1, sodium chloride.
All right, so he said sodium chloride. He said this is a +1. Symbol for sodium is? Na. Did I say, tell me the symbol for Na? Is that what I said?
Yeah.
Ah, all right, and then I need someone to give me chloride.
Cl.
Cl, and the charge? Anybody? -1. Excellent. All right. Now, to start, I would always do my charges. After a while, you guys will be able to do these and not write your charges because you're just going to remember. I know sodium's +1. I know chlorine's -1. All right. Now, on the video that I know everyone did last night, they told us to draw a box around it. Why did we draw a box around it?
It reminds you that you can't change anything inside the box.
Oh my gosh, Jamie, fantastic. Yes, if I do this, that means I can't change anything inside the box. So we don't get tempted to go back and add in subscripts or stuff that we can't do, okay? So NaCl, I put a box around it because I know that formula is now correct. Now I'm gonna go to lead 2 nitrate. So plus, we wanna do lead 2 nitrate. Symbol for lead. Symbol for lead. PB. John is on it today. PB. Does anybody, can anybody, two things. One, tell me what the charge for lead is and how you know that.
PD has a charge of +2 because it says 2 right there.
Thank you, Marco. Excellent. It says +2 because there is a 2 right here. That's what this 2 is for. It tells me what the charge of lead is. Okay, so lead is +2. And then this is nitrate, 888. That should give you a hint that you should be looking on the back of your periodic table. On the back of your periodic table, define nitrate. NO3. NO3. Excellent. And what charge?
-4.
-1.
-1. Joe's guessing away, but he's actually getting pretty close. Yeah. All right, so lead 2 nitrate. All right, so we got to make sure that this, sorry, I was trying to find a thing for Joe. I was trying to find you another periodic table. I got one from here. Is this formula correct yet? We can't box it yet because I don't think that formula is correct.
We need to add a 2 to nitrate.
All right, Marco says we need 2 nitrates. So here we go. Yes?
No.
Because they're not equal to 0.
Right, and Eric said we needed the parentheses because otherwise it looks like 1 N and 32 oxygens. Fantastic. All right, and if you are, let me see if I can switch. If you don't know where that NO3 came from, let me just show you super fast. It came from right here, right here. All right, so nitrate is right here, NO3, and it has a -1 charge. That's where you got it from, okay? All right, back here. All right, so now this is correct. I'm gonna box it so that I know, as Jamie said, I cannot go back in and change anything about that later on, okay? So I don't want to change anything about this later on. So I'm going to box this. Now here's the good thing, all right? We're going to draw our arrow. We already have all the symbols and all the charges. So we just got to put them together on the other side and make sure that we write the right formula. So for example, we already said that lead 2 was Pb and it had a +2 charge. And then we already said that chloride, okay, I'm right here if you're looking, lead 2 chloride. We already said that chloride was Cl and it had a -1 charge. Sorry, this was a +2, okay? Your charges carry over, not your subscripts, okay? Not your subscripts, which are the little numbers that sit low, but your charges do carry over. All right, Dominic, what would you do to make this formula right? I got Pb with a +2 charge and Cl with a -1 charge. What would you do?
You need another CL.
I need another Cl for a total of 2 of them. This now looks right because my charges cancel out. I would have a +2 and then 2 negative ones. Okay, so that looks good. So I'm gonna box this. And plus sodium nitrate. Annis, what do you want me to write? Sodium nitrate. You can either tell me the whole formula or you can just tell me step by step what to write.
Na, then NO3.
Na and NO3, and I'm assuming, and this is super smart, that he knew this was +1 and he knew this was -1, so those cancel out. So I'm going to box this. This is correct. All right, this is called our skeleton equation because we now have all the formulas and they are correct, okay? We have all the formulas and they're correct. I'm gonna go to a blank sheet so I can show you how to balance it now, okay? Go to a blank sheet. Oh no, that's the skeleton. So we got part of it done. All right, now let's talk about how we balance them. So why do you think we need to balance equations in the first place? There is a law that we are trying to make sure we don't break. What law is it? Law of
Conservation of mass.
yes, conservation of mass or conservation of matter. We cannot just go in and randomly start adding subscripts and changing stuff inside the box, but we cannot create or destroy matter either. So let's make sure that we balance the equation. We use big numbers to balance the equation. They start with a C, big numbers. What are they called? Anybody remember? Big numbers that we put in front. Start with a C.
Constants.
Close. Constants actually are big numbers that go in front. What did you say, Whitney?
Coefficient.
Yes, coefficients. So technically, Jamie, you are not wrong. They're all constants.
You are wrong, Jamie.
But we're looking for coefficients. Okay, so here's what we're gonna do. The first thing we do when we are balancing an equation, okay, when we're balancing an equation is do an element inventory. If you worked at the grocery store and they said, please go take inventory of the canned vegetables, you would have to go and count how many cans of green beans you have and how many cans of corn and how many cans of tomatoes and how many cans of peas you have, okay? So before we can do an inventory, before we can count, we have to know what we got. So I need you to tell me everything that you see, all the elements or group of elements that you see that are on both sides of the equation. Faith, can you tell me one thing that you see that is on both sides? I'll give you an example. I see Na on both sides of the arrow. Faith, what's something else you see on both sides of the arrow?
PB.
PB, excellent. PB is definitely on both sides. Joe, what else do you see on both sides?
NO3.
NO3. I like that Joe did not break that up. Okay, you absolutely could break it up, but you're going to create more work. If you see it and it looks the exact same on both sides, like you see NO3 stuck together, then keep it together. All right. And then what are we missing? Somebody tell me what we're missing. Cl.
Chlorine.
Yep, chlorine, Cl. Excellent. All right. So when you're doing your element inventory, okay, you can do it whichever way works for you. So here's the two different ways you can do it. You can count everything that's on the reactant side first, okay? Or you could say, hey, there's this many NAs on this side, this many NAs on this side, and then do each one. So you could do it either way, okay? It really doesn't matter. Just make sure you are careful when you're counting, because if you start to balance this and you're like, I cannot get this to work, you've either done one of two things. Either you're counting wrong, or more than likely one of your formulas is wrong, okay? More than likely one of your formulas is wrong. All right, Eric, can you give me the count for sodium on both the reactant and the product side?
2.
How many on the reactant side? How many on the product side?
On the product side, there's 1. On the reaction side, there's 1.
Okay, 1 on each side. So he said on the reactant side, there is 1 Na, okay? So remember, we don't write ones, but we can clearly see there's 1 Na over here. And he said on the product side, there's 1 Na, okay? Isaiah, how about PB? Can you tell me how many PBs you see on each side?
Wait,
Say again.
what did you say?
How many PBs, we're on this one right now, do you see on each side? So tell me how many you see on the left, and then tell me how many you see on the right.
1.
1 on this side, and on the other side?
1.
1. Excellent. All right. NO3s. Fisher, NO3s. How many do you see on each side?
1
1 on which side?
on the left.
1 on the left. Are you sure you see 1 on the left?
I don't know.
Okay. Tell me how many you see on the right, for sure.
I was gonna say 1.
Okay. And tell me, if you only see 1 NO3, what is this 2 for?
Oh, so that means there are 2 NO3s on the left.
Exactly. 2 on this side. Okay. So remember, PbNO3 2. All right. Let's flush this out just so we know how to count. Means that you have PB, and we said we needed 2 NO3s. So you have an NO3 and another NO3. That's what that 2 means. Okay. On this side, you have an Na and you have an NO3. Remember, this NO3 is what we're counting. It's not 3 of them. There's 1 NO3. Over here, there's 2 NO3s. Everybody understand that? Okay, when we're counting. All right. Cl. Ariana, how many Cl's do you see on each side, if you can tell me? Are you there, Ariana?
1 on
one on the left side?
Yeah.
Okay, and then on the right side, how many?
2.
2. Excellent. She sees 2 right here. Fantastic. All right. So now we have done our element inventory. We have taken count, and we can see that, you know, if I look at this, we have to get them to the point where they are balanced. We have the same number on each side. That's the whole point of balancing an equation. So my sodiums match, I have 1 and 1. My leads match, I have 1 and 1. But my nitrates and my chlorines do not. Now, remember, at this point, we cannot change anything inside the box. The only thing we can do now is add big numbers that are called coefficients in front of any of these. We can put a big number anywhere in front of these, but that's all we can do, okay? All right, so It doesn't matter if we do the nitrate or the chlorine first. Joe, which one would you like to do? Nitrate or the chlorine?
Chlorine.
He wants to do the chlorine. So we have 2 chlorines on the right side. We need to get 2 on the left side. What should we do to get 2 on the left side? John says, let's put a 2 here. Now, if I put a 2 here, that 2 distributes all the way through that box. So yes, I now have 2 chlorines, but what happened? I also have 2 sodiums, John says. Everybody understand that. That 2 gets multiplied through everything in that box. Okay. So now my chlorines are now balanced. My leads are still balanced, but now my sodiums are not. Okay. So, Whitney, what do you think? What would you want to do? We need to either balance the sodium or the nitrate.
The nitrate.
All right, what would you like for me to do to balance the nitrate?
Put a 2
In front of,
in front of the sodium nitrate.
all right, I'll put a 2 here. That's what Whitney said to do. That now gives me a new count, 2 sodiums. And it also changed my nitrate to 2. So let's see what we need to balance now. 2 sodiums on both sides, 1 lead on each side, 2 nitrates on both sides, 2 chlorines on each side. We are now balanced. This is now a balanced equation. Excellent. You balanced your first equation. Okay.
Wait a minute.
Yes.
So we started off with chlorine, so we had to balance that out. So we went to NaCl, right?
Uh-huh.
They added 2 there, so now there's 2 NAs. on that
Yes.
side.
Because you have to count again. You always have to. So every time you add a coefficient, you need to count again because it may change something. It may change more than just the thing you were balancing. Chances are it will, unless it's just a single element. Okay. All right. Any other questions about this one? Excellent. Please make sure that you have written down on your paper the balanced equation and the element inventory. You need both, okay? And this is why you should be writing as we go along because this is your homework and I'm gonna have to turn it in, Eric. All right.
Do you want my assignments I take off?
I don't think you want to use this. All right, so now let's go to number 2. Let's go to number 2. Ready? All right, I'm going to clear this. Clear my drawings. Go back to number 2. All right, number 2. Iron plus chlorine plus yields or produces iron 3 chloride. Before we do this, the other day we talked about elements that came as a set of twins. They were called diatomics, okay? Dominic, do you remember one of the diatomics? There are 7. They start with the number 7 and go over and make the number 7. And then there was one that was on its own. Dominic, can you tell me one of the diatomics?
You said the diatomics, right?
I did say the diatomics. That is correct.
Okay, nitrogen.
Nitrogen, excellent. He took the easy one. It's at number 7. So nitrogen is in 2. All right. Who has another one for me?
Fluorine.
Did you say chlorine?
Fluorine.
Up. She said fluorine. That's 2 of them, chlorine and fluorine. Very nice. Eric says bromine. That's 4. We got 3 left. One's by his lonesome self. Who are we missing that's by himself?
Hydrogen.
Excellent. H2. Got 2 more left. Marco, do you remember one of them?
Oxygen.
Oxygen, yes. One more.
Iodide.
Very nice. These are your twins. So remember, if they are by themselves, there's probably a reason I just did this again. If they are by themselves, then they come as a twin. All right, so let's start number 2. Let's start number 2. All right. All right. Miss Jamie, are you there?
Yes.
Do you remember the symbol for iron? If not, you can give me the symbol for chlorine. Whichever.
CL.
Cl. Now he is by himself, so what should we make sure we do? It should be something else, not just Cl. Anybody remember?
The 2.
Should be Cl, excellent, Cl2. He is a twin. He's by himself, meaning he's not combined with anybody else. All right, there's chlorine. All right. Anybody found iron yet? This is Fe, excellent.
Fe.
Fe, excellent. All right, iron, sorry, I went kind of backwards because I let Jamie give me chlorine. So here's Fe. All right, he's just by himself, so that was good too. So I'm gonna box that one. Fe plus Cl2, iron 3 chloride. This is again, listen to me carefully. Subscripts do not carry over. You cannot say, oh, I have an Fe and I have a Cl2. I'm just gonna put FeCl2 on the other side. You cannot do that. They said that Fe and Cl2 make iron 3 chloride. Iron 3. We know that iron is Fe because Whitney just told us, and we know chlorine is Cl. It is not by himself, so he does not need the 2. He's joined with someone else, okay? So you do not have to keep him as a twin, okay? Marco, charge for iron, please.
3.
3, excellent. He knew that because there's these nice Roman numerals right here. So this is +3. Somebody give me the charge for chlorine. Anybody?
-1.
Very nice. -1. All right. Brandon, if I wanted this to be equal to 0, do I need more irons or more chlorine? And if so, how many? So you can add some more irons or you should add some more chlorines, but I need this to be equal to 0. Right now I got a +3 and a -1. What you think? All right, somebody help him out.
Would it be 3?
Are you saying 3 total, Whitney?
Yeah.
I agree with you. You need 3 of these. Okay, so that would be like Fe with a +3, and then you need a Cl, another Cl, and another Cl, -1, -1, -1. That does equal 0. Very nice. So FeCl3, this formula is now correct. So let's box it up. All right, let's get ready to balance it now. Okay, all right. All right, here we go. Element inventory. Element inventory. This one's pretty easy. Cameron, can you tell me what 2 elements you see? You don't have to tell me the names. You can just tell me the symbols or the letters. Are you there, Cameron?
Iron and chlorine.
Very nice. Iron and chlorine, Fe and Cl. That's what I see on both sides. All right. So now we just have to count how many we have on each side. You can do it however you want. I'm going to let you count first, and then I'll put the numbers up. You just make sure you got the same numbers that I did. Okay. So you should be doing your counts. Did you already do your counts, Joe? You got it out? Okay. Try it out. right, Fisher, how about you give me my counts, whatever you want to give me.
On
If you're talking, we can't hear you. I heard you for a second, then you went out. You there, Fisher?
yeah, I'm here. You could. Sorry, my connection got messed up.
It's okay. Can you give me
Um,
counts for these?
On the left, there's one Fe,
Okay,
and then on the right, there's one Fe,
okay,
and then on the left, there's two Cls,
very nice.
and then on the right, there's three Cls.
Excellent. All right, fantastic. So now we got our element inventory. All right. So now we just need to balance it. Now, it's really easy to balance when one of them is a 1 and the other one's a different number. If it's not 1 and some other number, we probably need to find a common multiple because listen, if I have 2 CLs over here, there's no possible way, whatever number I put right here, there's no way I can get 3 chlorines. There's not.
Would it be 6?
Excellent, Whitney. We need to find at least common multiple, and Whitney said we can get it to 6. So Whitney, what number would you want to put where I just drew that arrow to get that to 6?
I will put wouldn't it be a 3?
All right, let's see if you're right. If I put a 3 here, 3 Cl2s, that's a Cl2, a Cl2, Cl2, 2, 4, 6. That is 6 chlorines. You are correct, Whitney. Great. Now we need to get 6 on the other side. How do we get 6 chlorines on the other side?
Oh, yeah.
What do you think, Joe?
Hmm?
We need to get 6 chlorines
Put 2.
over here. Joe says put a 2 here. Excellent. That now gives me 6 chlorines on that side because that 2 goes all the way through that box. So yes, it gave me 6 chlorines, but it also gave me 2 Fe. Excellent. All right, so now one more thing. What do we need? A 2 on the other side. You're right. Excellent. All right, here's our balanced equation for number 2. Let's just double check. I got 2 Fe's. Let me make sure I write my 2 here so I don't forget. This was 2 now. 2 Fe's on each side, 6 chlorines on each side. This looks balanced. Fantastic. Okay. All right. Again, make sure on your sheet you have the balanced equation and your element inventory. Okay. All right. We're going to do number 3. And then you guys either individually or with other people are going to do 4, 5, and 7. And I'm going to give you some hints on number 4. Okay. All right. Here we go. Good. I'm going to clear this now. Clear. Oh, no, I don't want to clear. I just want to erase. Ah. All right. So number 3, I think it says barium. Actually, I know what it says. It says barium plus water yields barium hydroxide and hydrogen, I think. Let's make sure. It does. All right, so let me zoom a little bit. Or let me scroll down, I should say. All right. Barium. We need barium plus water yields barium hydroxide plus hydrogen. Okay. Barium. Anybody got my symbol for barium?
BA.
Excellent. BA. All right. And we can do the charge now or we can do it later, but at least we know that BA is correct. So I'm going to just put it here. Anybody know the charge of BA?
Would it be 1?
I heard +1 and I heard +2. Which one's right? It's in the second group, so it should be +2. All right. So that's barium. And then we got plus, anybody know the formula for water? It is dihydrogen monoxide. That's the actual formula for water. Dihydrogen monoxide. What is water though?
H2O.
H2O. Excellent. H2O. Okay. Now, notice what I call that, dihydrogen monoxide. How is that different? How's that different than what we've been doing so far? It's different
Because you have the like the dye.
exactly. This is covalent. This one was covalent. Okay. All right. So you can mix ionic and covalent when we start mixing compounds. All right. On the other side, good job, Whitney. On the other side, we got barium hydroxide. All right. So we had the barium that was Ba, and you guys told me +2. Hydroxide, this is a polyatomic. So see if you can find it. Somebody see if they can find it. Hydroxide. It's a polyatomic. So you should be looking on the back of your Chem Cruncher. OH, excellent, John. Charge? -1. Fantastic. All right. Brandon, are you there?
Yeah.
He's so excited to answer this question. He's so excited to call on him. I know you were waiting on me, Brandon. That's why I called on you. All right, Brandon, I need these to be equal to 0. I got 1 barium. I got 1 hydroxide, +2 and a -1. What other number could I put right here to get to a -1? Can I do another barium or another hydroxide?
Say that one more time.
Do you want another barium or another hydroxide? These numbers, stick with them. We're trying to get to 0.
Well, you wanted that hydroxide.
Yes, excellent. See, we need another hydroxide for a total of 2 of them. Okay, for a total of 2 hydroxides. Okay, we need another hydroxide that will give us a total of 0. Now, somebody tell me, let's see if somebody catches it. All right, here is my second hydroxide. Is that right?
What about the oxygen?
What about the oxygen? If I were to do an element inventory right now, it looks like I have 1 Ba, 1 oxygen, and 2 hydrogens. But Brandon said we needed 2 hydroxides. So how do I make sure we know that this is 2 hydroxides and not 2 hydrogens?
Parentheses.
Excellent. Yes, we need parentheses. All right. So there's my hydroxide. Okay, 2 hydroxides. All right, so that's the barium hydroxide. And then it says plus hydrogen, plus hydrogen. So plus, oh, sorry, let me box this because this is now correct. All right, and plus hydrogen. What should I put for hydrogen? Anybody? John says H.
H2.
H2, good. That's the other thing. So parentheses and diatomics is what would trip you up when we're doing these, okay? So you just got to kind of remember those. I would think it's a good idea for in the beginning, you just to go ahead and write your diatomics on the side like I did, so you remember. All right, everything's boxed. Let's get ready to balance, all right? So we had the polyatomic hydroxide. We got a Ba, okay? We have hydroxide. It's technically not on both sides. I mean, you could kind of pretend this is HOH, but technically it's not on both sides. So I would just break it up. I would just do O and H, okay? Because like the NO3, when we just did it, it was on both sides. But if it doesn't look like OH on both sides, then we can break it up. So let's do O and H. All right, Miss Faith, do you want to give us counts for either, you want to give us a count on for everything on the left side? So how many bariums, how many hydrogens, and how many oxygens on the left side?
For barium 1,
Okay. How about oxygen and hydrogen on the left side still? So everything over here.
There's one on the left for hydrogen.
One on the left for hydrogen or oxygen?
Oxygen,
Yep. And then how many hydrogens on this side do you see?
2.
2. Excellent. All right. Whoever does the other side, you can volunteer, but be very careful. I see hydrogens in 2 different places. So be careful of that. So now we're doing the other side.
For BA, there's 1.
Correct. There is 1. All right. Let's see if you get this, Miss Whitney.
For oxygen, wouldn't it be 4?
Wouldn't
let's-
it be?
It is 2. All right. So you got an OH and then you got another OH. So you got 2 OHs. So how many now, Whitney?
Oh, 2.
2. Excellent. All right. So you got these 2 OHs and then you got another H2 over here. How many H's do you see total now?
3.
You sure?
Oh, wait, no, 4.
4. Excellent. All right. 4 on those. So again, we just got to be really careful when we count. Okay. And we just got to get used to counting. That's all. All right. So anybody want to tell me what they would do as far as coefficients? What do you want me to put somewhere? Okay. John says, now I don't know if he's trying to balance the oxygen or the hydrogen. He didn't tell me, but he said he would like to put a 2 in front of, because the bariums were already balanced. So he said he would like to put a 2 in front of H2O. Okay, so I put the 2 there. We're going to count again. This 2 gets distributed all the way through this box. So you would do 2 times 2 to get your hydrogens and 2 times, remember there's an understood 1 right here to get your oxygens. So that would give me 2 oxygens and 4 hydrogens, and that is balanced. Excellent. Fantastic. Okay. All right. So I'm going to give you a second to get that down, and then I'm going to talk to you about number 4, 5, and 7. And you have the rest of class to do those 3. Take a picture and turn it in. Okay. So I'm going to talk about those, and then you'll just finish that up. And you can work with each other on those if you want. Okay. All right.
Do we also take a picture of 1 through 3?
Yes, so ideally, I would just think you would do 1, 2, 3, 4, 5, 7 on the same sheet and take a picture. Okay. All right, I'm going to clear this. Let me talk to you about number 4. Okay. All right, let me go back. So on. All right, number 4, 5, and 7. So those are the ones you're going to do. We're going to skip number 6 just because it is kind of tricky to balance. But that's because it's a certain type of problem. We'll talk about that.
Do I have to write down the problem?
No. All right, here's 4, 5, and 7. Give me 1 second. Let me make this a little bit smaller. Oh my goodness, come on. Ooh. All right, give me 1 second. I'm trying to make this smaller, and it is not getting smaller. All right. Yes. Wait, can you hold for just a second? All right. So let me talk to you about number 4, 5. So we're not doing number 6. Okay, we're not going to do number 6. All right. On number, let me write these again. H2, N2, O2, F2, Cl2, Br2, I2. Is that 7? 1, 2, 3, 4, 5, 6, 7. All right, don't forget those. All right. This first one, number 4, it says chlorine gas. It's just chlorine. Okay, so the gas doesn't mean anything. So just don't forget that that's a diatomic. Methane, the formula for methane is CH4. Okay, you need to know that. Okay. Then it says carbon tetrachloride and hydrogen chloride are produced. What does that mean in terms of where you write it? says carbon tetrachloride and hydrogen chloride are produced. They're on the right side, so that means that's on the other side of the arrow, okay? Hydrogen chloride, this is technically hydrochloric acid. It's just HCl, okay? That's what that one is. All right, number 5, I think you'll be okay. Number 6, number 7, I think you'll be okay. Be very careful on number 4 when you're counting, because you may have a carbon and a chlorine next to each other. So just be careful with the C's, okay? All right. I'm gonna put you guys in some breakout rooms. You can tell me which room you want, or I'll just break you up. And you're gonna finish these and upload it to word equations number 1. It's the one that says it's due tonight, okay? I will help you if you need any help. You guys did better than, sorry, I shouldn't say you did better than other classes. You guys have more time to work on than other classes. So let me just put this up. I'm trying to stop